So what I'm going to talk about a little bit this morning started with that history 25 years or so ago, and will come up today. But we're here to talk about green. If we paint something green, does that make it green? We like to see lots of green out there, don't we? Green is good. The green industry, the green revolution has taken over. We now have eco-shaped bottles, plastic water bottles full of water that the nice people at Poland Springs want us to think is green. The fact is that's plastic. It's PET. Anybody have any idea how many of these we make every year? About 200 billion half-liter plastic water bottles per year. If you put them end to end to end, that's enough to go from here to the moon, which is 239,000 miles, and back to the moon and back 40 times. From here to the moon and back 40 times. But they would like us to think that their new thinner bottle, smaller label, is advancing toward green. I'm sorry, I don't think it is. In 1987, the Brundtland Commission of the United Nations came up with this definition for the term sustainable development. It is social and economic advancement to assure human beings a healthy, productive life, but one that does not compromise the ability of future generations to meet their own needs. Does not compromise the ability of future generations, our children, our grandchildren, our great-grandchildren, all those who will come after us, forever into the future to meet their own needs. Think about that for a minute as we continue the discussion today. This is a chart updated last year, in July of 2012, from the U.S. Census Bureau. I'm sorry, this one is 2007. It's basically the same thing. It shows our population today of almost 7.1 billion people on the planet. By the year 2050, 37 years from now, 1.5 generations from now, we will have about 9.3, 9.4 billion people. That's another 2 billion people in addition to what we have today. When I was born in 1951, we had 2.5 billion people on the planet then. We have almost tripled the size of the world population in the time since I was born, in the last 62 years. This is what India will look like in the year 2050. India will be the largest nation on the planet. India will have 1.7 billion people, or 19.8% of the world's population. 1/5 of the entire world's population will live in the country of India 37 years from now. You will have 300 million more people than China does today. India will surpass China in the year 2040 as the largest country in the world. Is India ready to sustain itself in food, clothing, and shelter? Do you have fashion technology and advancements in chemistry, in production, to clothe and feed and care for and shelter 1.7 billion people? Now, the chart that I showed you a minute ago only takes us to the year 2050. The question then becomes, what happens after that? What about the year 2100, 2150, 2200, 2300? Are we going to have 10 billion? 12 billion? Some people suggest by the year 2100 we may have 16 billion people on this planet. 16 billion, twice plus the population we have today. Now, from a demographer's viewpoint, if you want to take a look at this real quick, think about 2050. The majority of people in India are going to be male. There's slightly more men in India than there are women at that point. Where are all those men going to work? Where are they going to find wives if there aren't enough women to marry? From a demographic viewpoint, that's something to think about. Not for this conference, but something to think about. Now, let's talk about atmospheric carbon dioxide, what we call a greenhouse gas. Everybody says, oh, poo-poo, it's no big deal. Well, at the top of a mountain out in the middle of the Pacific Ocean in Hawaii, they've been measuring carbon dioxide in the atmosphere since about 1960. We're almost at 400 parts per million today. It's one of the reasons the atmosphere is warming up, the oceans are warming up, and we're getting some big drastic changes in weather, including where I live in the United States. If we go back to the year 1000, that's what's happened to atmospheric carbon dioxide. So what happened? Somewhere along the Industrial Revolution, we started burning coal, and then we found oil, and we found natural gas, and we started burning it like crazy, and all of a sudden we started pumping all these greenhouse gases into the atmosphere. Wow. Let's go back about that same time frame. There's a worldwide population. 1 billion people on the planet in the year 1750. To 9 billion today. Wow, 300 years. We've had 8 billion people. That's a big change. Is your technology or your green initiatives ready for this kind of additional population growth? Let's look at global temperatures for a second. Everybody says, oh, come on, this greenhouse gases, climate change stuff, this isn't real. Well, again, these are real measurements. This is real science. This is the average 5-year increase that says we're going up about almost a half a degree Celsius in worldwide temperature increases. And that chart doesn't say we're coming down. It says we're continuing to go up. Now, where does our apparel come from today? Where does the raw material come from? Is it all wool, cotton, silk? Is it all renewable resource? No, about half of our apparel today is made from synthetic fibers, which are oil derived. According to this chart, which came from the International Energy Agency, we've used about half of the oil that's in the ground. And we're on the downhill slide. There's world oil production projected through the year 2080. You can see right now we're just about past the halfway point. And we're going to see continuing downward trends. Now I stayed in the hotel last night, and sitting next to me at the bar last night having a drink was a young man who's a geologist from Houston, Texas. He's a Canadian, and we talked about world oil reserves, and he said, oh, poo-poo. All this stuff, we're running out of oil, that's garbage. We're not. We got plenty of oil. I said, really? He said, well, we're finding a little bit more here and there, lots of natural gas. But oil, we know what we've got, and we've got new techniques to get more and more out of the ground. I said, okay, that's nice. At what cost? At what environmental cost? At what fiscal cost for us? And it's still a finite resource. When it's gone, it's gone. It's like eating an apple. We've eaten half of the apple so far. We've only got one half left, and that's the last one. Here's our worldwide coal production. China's running out of coal. The United States has a bunch of them. We're actually looking at exporting coal to China. Again, when it's gone, it's gone. And we're almost to the halfway point. Coal, by the way, is really nasty stuff, and you can't make fabric or textiles from it. Everybody says, no problem, I can run my factory on nuclear power. Really? Cool. Go build a nuclear power plant, see how long that takes you. Today, there is not one nuclear power plant on the drawing boards anywhere in the world. After the Fukushima disaster in Japan, they started shutting down their nuclear power plants in Japan. The French are doing the same thing. Most of their power today in France comes from nuclear power. They're systematically starting to close all of their nuclear power plants. They're going back to burning coal. Now, why is that? Uranium is also a non-renewable resource. There's only so much of that in the ground. When it's gone, it's gone. Current worldwide reserves say somewhere around 2035, 2040 we will have probably used up most of the nuclear power that we have. That's it, game over for nuclear power. All right, it's not time to go out and slit your wrist yet. We can figure out some solutions, but we're going to have to work together. The year 2050 and beyond, when many of you young ladies in the back of the room are about my age or a little younger, so look at you in the back of the room. Hi. The students, you are the next generation. You're my children's age, my grandchildren's age. You're going to have to make some pretty tough choices, and we all are along the way. Our non-renewable resources of oil, coal, natural gas, iron ore, copper, some of these are renewable. Lithium, it's not. We can recycle it a little bit, but we don't do it very well. Gallium and all of the things that we make solar panels out of, we're using up. Unless we start building windmills and solar panels and hydroelectric power very quickly, we're not going to have electricity either. We need to figure out how to build renewable energy sources to power our homes, our transportation, our factories. We need to have renewable energy to power our homes, our factories, and our transportation. Otherwise, we're not going to be moving anything around the world. Think about trying to have this conference this morning with no electricity. We are in a dark room. The lights are out. Computers don't work. Period. We're in a dark room. There's no air conditioning. In the back, there's no place to heat the water or cook the food. We're all sitting outside the parking lot in a big group, holding hands, shouting at each other, because the microphones don't work either. Think about your daily lives and how you're going to run your life and how you're going to run your business without power. Global warming? We don't know. How far is Mumbai from the ocean? How far is the ocean from here?
Half kilometer.
How long?
Less than half kilometer.
Less than half a kilometer. You mean we're right next to the ocean? Oh, that was that water I saw when we flew in the middle of the night. Yeah. What happens if the sea levels start to rise? There was a discussion yesterday on BBC that some of the people thinking about London, England, are really worried that London could flood. So could New York City, so can Washington, D.C., so can Hong Kong, so can Singapore, so can Shanghai. Some of the biggest cities around the world could be underwater. Current projection is by the year 2200, the southern third of the state of Florida in the United States could be underwater again. A third of the entire state of Florida and much of the Gulf, much of the coastline of the United States, and the world could be underwater again. How are we going to feed everybody? How much water does it take to make a cotton shirt? This is a 100% cotton shirt that I'm wearing. I'm not going to show you, but my underwear are 100% cotton too. There's a little bit of spandex in the waistline. How much water does it take to grow and process a pound of cotton and turn it into a garment? Anybody know? It takes a lot. It takes 14,000 gallons to make 1 pound of meat. Where are we going to get all that water? And as I said earlier, synthetic fabrics that are mainly oil-derived, which are 50% of what you make today, are going to be a real challenge. So the question for you is fashion green? How green is fashion today, and what do we need to do to make it green and sustainable for the future? The issues of labor and environmental compliance, chemical compliance, working with dangerous chemicals and getting them out of our system, using natural dyes and colorants, that is going to be critically important. To me, the bigger question is, how are we going to run the entire industry, and how are we going to feed and clothe everybody? So what are some of the suggestions that I would say? For now, embrace lean manufacturing. How many of you know what lean manufacturing is? Raise your hand. Study up on lean manufacturing. Lean is basically taking every bit of waste out of your manufacturing process and making it as lean as possible. We've all heard reduce, reuse, recycle. I would add 2 more words to that. Refuse. Refuse to put any input into your system that doesn't contribute to the output and in making it more green or more sustainable. By and large today, I refuse to drink out of plastic water bottles. The water in this hotel is just fine. I drink tap water. We also need to re-engineer our process. A colleague and I were sitting here this morning talking about indigo dye. That synthetic indigo and natural indigo today are made and have basically the same chemical breakdown properties. Can we rely upon Dystar and others to help us invent and come up with new formulas, or we can re-engineer the manufacturing process? I read an article the other day that a competing company to Dystar has reduced their energy consumption by 45% in the last 3 years. 45%. They've reduced their water usage by 46%. All sorts of significant numbers that you're going to rely upon. Levi Strauss, in fact, is today suggesting that rather than washing and drying their blue jeans, wear them about 10 times, then put them in the freezer. It'll kill most of the bugs. Shake them out, put them in the sun, and after you wear them about 20 or 30 times, throw them away and buy a new pair. Because the energy to wash and dry your clothing far exceeds the energy necessary to make a new garment. And from a pure energy standpoint, you're better off wearing it as much as you can until you can't stand it anymore, and then throwing it away and buying a new one. I'm not quite sure I buy that. I do like to wear clean underwear. I can maybe wear a shirt a couple days, but socks and underwear, that's got to change. How much packaging can you eliminate? How can you move to renewable chemicals and renewable every part? Instead of making garments out of synthetics, can you make them out of renewable fibers? Cotton, wool, linen, flax, silk. Naturally derived, and I'm not talking about acetated rayon, and don't even talk about bamboo. Bamboo is, in my view, one of the nastiest things you can make. It's not really bamboo. And then seek out some long-term suppliers. Look for suppliers that are as close to your business as possible. Moving raw materials and finished goods is incredibly expensive. Go to meetings and adopt all the best practices you can find. Study your competitors, study the industry, study other consumer products industries. What's Procter & Gamble doing? What's Unilever doing? Do they make apparel? No, but they make other consumer products. Procter & Gamble has pledged 0 waste to landfills, 0 packaging waste, all renewable materials and all renewable energy. Apple Computer, for their big data centers, already have 100% renewable energy that powers their data centers. And solar power and wind power. Are you doing the same? As I say, look at how you can create a truly sustainable business. Not one that is green or green washed. That we paint green and we put a nice green sign on the front door. That doesn't make you green. In fact, one of the questions you may want to consider later on with the panel, and I'm almost done, so you don't have to ding the bell, is how do we define green? And then finally, I'm a natural optimist. I try and find solutions. I believe that we can find solutions. So my final recommendation is to stay positive, but also pray a lot. Thank you very much.